And so I will give the microphone to Josep. Josep, if you can share your screen.
Okay, do you see my screen now?
Yes, perfectly.
Okay, so thank you, Laurent. Good morning, everyone. Thank you for attending this very important webinar. I'm very glad to present to you the ARIADNA project today. Let me start with some brief information about the project. This is a coordination and support action which is funded by the European Agency for the Space Program. And the project started back in December 2019, and it will end by November this year. So it will be a total of 24 months of project. So we still, we are 5 months for the conclusion of the project. This project is led by a consortium of 5 partners from 3 different countries. It is coordinated by my company, Factual, which is an innovation and strategy consultancy focused on mobility. We are also the coordinators of another project also funded by the USPA, which I will refer to later on, called Molière, which is very relevant for the kind of activities that we are promoting in the ARIADNA project. We are glad to have in the consortium the UITP. And they are mainly dealing with communication and dissemination activities in the project, and they are our main contact with the public transport sector, being the main public transport organization worldwide. Pildo Labs, it was mentioned earlier by Laurent, is an SME based in Barcelona, who are specialists in the space sector. We have the Polytechnic University of Catalonia, who are dealing with stakeholder engagement and technology transfer towards the industry of solutions that are based on Galileo applied to human mobility and public transport. And last but not least, we have Auxilia, who are our hosts today of this webinar. And their main role in this project is to make sure that all of our activities are well received and all of our coaching and advice towards the SMEs and startups are maximized. So the objectives of the project in a nutshell are to raise awareness about the technical advantage of using Galileo and other space technology such as Copernicus in the urban mobility space, and in particular in public transport, mobility as a service, and all of these new mobility paradigms where geolocation is critical for the operation of these services, along with raising awareness and informing to different stakeholder communities on the existence of Galileo and why it pays off to use it. We want to, in this process, to build the capacity of decision makers, of different players, to educate them on the availability of these technologies and how best to use them, and provide them with all the coaching, with all the tools and the knowledge that they need. And last but not least, because we want to increase the level of understanding of Galileo technologies in the public transport and urban mobility domains, we want to help different players in different markets worldwide. That's our scope. We are not only being a European funded project does not mean at all that we're only targeting Europe. Our approach is global, being Galileo a global navigation satellite system. Many people still think that this system is regional, but this is not the case at all. It is available for free at a global level. So we want to facilitate that more and more. In this case, in particular today, small companies, SMEs, startups interact with all the players in this market and make the most of the opportunity of using Galileo in this case. So because one of the objectives of this project is to inform our audiences on what Galileo is about, let me just brief you, give you some hints. So the Galileo constellation, it is composed of more than 20 satellites. Like any other GNSS system available today, like GPS, which is arguably the most well-known. So these are, roughly 20 satellites, and there are since December 2016. So it was not yesterday that this constellation was launched, and it offers a number of services, being the first one called Open Service, the one that is most relevant and most adequate for public transport and urban mobility in general, which provides positioning, timing, and navigation message authentication to a range of applications. This is a snapshot of the applications where GNSS, and in particular Galileo, can make a significant contribution. If it's on the smart mobility space, providing geolocation, very accurate geolocation for fleet management, even if these fleets are of public transport or are of shared mobility services or whatever, providing more and more accurate information to passengers, to end users, to reduce the friction when they make use of these services, so that they can locate the vehicle that they need to use at all times. There are a range also of applications related to liability or safety relevant applications. Here's only a snapshot of those applications. I leave it to Sergi, who will speak after me, to explain how we have compiled all of these applications and use cases in a very important document that we have generated in the project, which is freely available to everyone, which is the white paper that Sergi will present later, and that you can download freely through our webpage. So coming back to Galileo, if I had to summarize why it pays off, and it is very relevant that you all know about its technical characteristics, it offers superior performance in challenging urban environments, where it provides more accurate geopositioning and faster fix of the location of moving vehicles or end users as well. So Galileo, in other words, is an enabler of more efficient urban mobility, given the fact of the stringent characteristics of the urban environments, where you typically find very tall buildings, urban canoeing effect, multipath, all of these effects, especially in very dense urban areas, which make it, in some cases, very challenging to geolocate vehicles or users. Something that is very important is that we are not at all saying in this project that you rather use Galileo than other GNSS. It is not the case. What we are saying is, look, because Galileo is fully available together with, and at the same time, of other existing GNSS systems, such as, for example, GPS, which is one of the most well-known. Why don't you use all of them and not only one constellation, which has been the case typically with many existing systems for geolocating and managing, for example, typically public transport fleets. So multi-constellation pays off, where it means that receivers are not only capable of using GPS, but also capable of using many other, all other constellations available in view, because it is very well known that in order to geolocate a vehicle or a user, especially when you have tall buildings or, as I said earlier, difficult and very challenging urban environment, you need at least 4 satellites in view. So if these 4 satellites in view, as you see in this figure, are from different constellations, then you're fine. So you might have a satellite in view that is from Galileo, and some others that come from GPS or from GLONASS or from Beidou, and all in all, using a multi-constellation chipset, it will give you more accurate, faster geopositioning. So that's one of the benefits of using Galileo, so the use of multi-constellation. Multifrequency is a specific feature of Galileo technology, which gives the system increased robustness against mass market jammers, or systems that are designed to interfere with the signal that comes from the satellite and try to trick it. So as Galileo operates, can operate in different frequency bandwidth, it provides more robustness against this kind of interfering. And last but not least, with multipath, which is the reflection of the signal that comes from satellites on tall buildings, generating problems in the receivers to determine the most accurate geopositioning. The fact that Galileo uses an advanced code modulation in different frequency bands, it makes it more robust against the multipath effects as compared to GPS, for example. So framing the scope of today's webinar, it is important that you know that this project, ARIADNA, has been addressing the 6 stakeholder groups that you see in this figure. So the public transport authorities, public transport operators, then the cities who want to implement more efficient mobility strategies in the cities. Then we have academia and research centers, and that's where we have, for example, in our case, the Polytechnic University of Catalonia to represent this wall of universities and research. We have technological providers that provide the hardware and software that use all of these applications in urban mobility, that we want them to make more and more use of Galileo. SMEs and startups, which are the focus of today's webinar, and last but not least, end users. So if we look at startups and SMEs, I think that one of the competitive advantage that these kind of stakeholders have and make them particularly interesting for the aims of our project is that typically a small company or a startup do not have so strict legacy requirements, meaning that, for example, when we approach public transport operators or public transport authorities, their decision-making process takes longer because they are much bigger organizations with much bigger budgets, and the technological evolution of their systems typically takes longer because they have to undergo public procurement processes, and it's a more lengthy process to introduce Galileo in this sector with public transport operators and authorities. But we're still pushing, and we have a number of successful use cases that we have compiled in our white paper that you can read later. But when it comes to startups, these typically are companies that are more flexible and more willing to integrate state-of-the-art technology to differentiate themselves from their competitors. And that's where I truly believe that using Galileo and getting to know more and more what it has to offer as a competitive advantage for this kind of actors is very relevant. So in terms of stakeholder engagement, as I said, we are addressing all of these stakeholder groups that I mentioned earlier. And in order to do that, what we did is we have built what we call the Space for Cities Forum, which is composed of roughly 20 organizations. Some of them, at their turn, integrate many other partners, such as the Smart City Institute Japan, which integrates dozens of other organizations, very important ones. We have Open and Agile Smart Cities, Eurocities, some municipalities, some technological providers. So this is still public transport operators and authorities as well, as you see. And this is only one instrument or one way for interacting with the ARIADNA project. However, we are more than open, and this is a key message that I want to give you to all the attendants to this webinar, that we are at your disposal for whatever need you might have, because ARIADNA is a flagship project dedicated in particular to highlighting the benefits of using Galileo in the urban mobility domain. So we have a very skilled consortium that is able to address all of your concerns, all of your questions, all of your whatever need you might have. So you have this expert support at your disposal for free, of course, because we are a European funded project. You will have early access to all of the official deliverables that we generate, such as the white paper, but in the weeks to come, you will also have access to other interesting documents, such as, for example, a paper that we are about to submit and has been already accepted to the ITS World Congress, where we will describe in more level of detail some very relevant use cases of startups, for example, in this case, and other agents using Galileo for different applications in urban mobility. You will be able to influence activities in this space because we will give you, the right dissemination to what you guys do. In terms if you want us to help you position your products, your ideas, as we are doing, for example, with players such as Revit today. You will have the possibility to network, to interface with many other players in this market. And last but not least, as I said earlier, through these activities, we are aiming to increase the level of understanding of all of these players on what Galileo has to offer. As I mentioned earlier, this is the white paper that Sergio will introduce in a moment. It is already available for download through our website. And last but not least, let me mention that something that will sound very familiar to many of the startups today attending this webinar, which are hackathons. We decided that because the ideas or fields of application of Galileo are endless, we decided not only to think ourselves on potential areas of application of Galileo, as mentioned earlier, but also to open the floor to innovators, to startups, to SMEs, to students who might come with fresh ideas how to best use accurate geolocation, making use of Galileo to address different challenges. So we had first edition of the ARIADNA Hackathon back in November 2020. Where we had 11 teams from all over the globe participate. As I mentioned also at the very beginning, we are also coordinating another USPA-funded project called Molière, where we also, this is a research and innovation action, meaning that we are not only disseminating the benefits of Galileo, but also actually implementing a mobility data marketplace underpinned by blockchain, where we share mobility data, and we challenged all different stakeholders to provide ideas for addressing urban mobility challenges by making use of this data, where Galileo provides the geolocation. So that was another hackathon that we organized, and you need to know that the second ARIADNA Hackathon will be announced and its challenges very soon. So if you are connected to our channels, to our website, to our newsletter, or to our Twitter, you will soon get to know when the second ARIADNA Hackathon is launched. And I encourage all of you to participate and provide us with your ideas. That's all from my side, and I'm more than happy to address any questions you might have.
Okay. Thanks a lot, Josep. Maybe we can directly switch to Sergi.
Hello, good morning, everyone. Let me just put my screen on full screen mode. Yeah, you can see it?
Yes.
Great. All right, thank you, Josep, for this on-point introduction to the ARIADNA project and to Galileo. Let me introduce myself quickly. I am Sergi Paniagua, and I am a project manager in the ITS department in Pildo Labs, the Intelligent Transport Solutions department. Pildo Labs being an engineering company specialized in geolocation solutions for the aerospace and aeronautics sector. So thank you also the audience for being here. I hope that by the end of the session, you'll feel like you got something out of it. So the goal of my presentation today is, on one hand, to share some insights with you about the work we've carried out so far in the ARIADNA project, and on the other hand, explain to you how we can support you in the coming months and what's left of the project. So regarding this first part, the work we've carried out so far in the project, I want to share with you insights about this white paper. It's a document we've elaborated, and it's about GNSS technology in urban mobility and public transport. And just a quick reminder, GNSS meaning European Global Navigation Satellite System, also known as Galileo. The goal of creating this document was first to educate about Galileo, so explain what it is, when it was created and launched and put into service, and why and what it means to Europe. Second objective was to illustrate GNSS benefits to all the different stakeholders in the mobility sector. So explain how they can be impacted by GNSS. And the third goal was to guide these different stakeholders in how to exploit these benefits. So not just explain the benefits, but also tell them how they can exploit them. And ultimately, the goal of this document was that it was meant to be an understandable document by different stakeholders, cities, mobility providers, without any previous knowledge about geolocation. All right, so let's jump in some of the information that you will find in the white paper that is available on our website, as Giuseppe said. And a big part of the document was gathering all the different applications that geolocation could have in different urban mobility services. For my presentation, I'm going to explain these applications in two different services, obviously because I would spend too much time if we covered them all. So the first service I want to explain about is the DRT, Demand Responsive Transport. For those who are not familiar, they're this kind of services operated usually with vans or minibuses, where users can request their trip, and the platform tries to pull as many passengers together as possible. So what are the applications of geolocation in this kind of service? Well, for fleet management purposes, so the vehicles that are operating with this software, DRT technology, they share their location in real time, and then the bus operator from the control center or the transport authority can track where every vehicle is at any time. Also, obviously, for providing the service, it's used because most of the times these services don't use physical or even virtual stops. A lot of times these services just use a location shared by the user. So for example, if you want to request a ride, you just tell the platform, here I am, and this is where I want to be picked up. So this position has to be computed by the platform and then given to the driver so that the driver will have the route to pick up the user. Also, it's used for sharing information with users. So on the user app, you could be either displaying where the different vehicles using the DRT technology are in a given area, or just display the vehicle that's going to pick you up. So if you're waiting for a vehicle and the vehicle has been assigned to you, being able to track on real time where the vehicle is. And also obviously to provide an estimated time of arrival for users. So with the position, real-time position of the vehicle and the location provided by the user, you can create an estimation of when you're going to pick up the user. It's also used regarding service quality control. So for example, if you're looking at aggregated historical data from your own service as a DRT technology provider, you can see what are the locations that were most requested in a given area, what are the streets that the vehicles drove through the most, and this gives you information about what areas of the city have a bigger demand, and you can adjust and redesign the service according to this. And lastly, a not so obvious one, but if you're also looking at historical data about how these vehicles have been moving, you can analyze the impact that they're having on traffic patterns in the city. Now that we've seen the different applications of geolocation on a DRT service, let's see what impact Galileo and the European satellite constellation has on this kind of service. So when it comes to fleet management, what can happen many times is with single constellation receivers is that as soon as the vehicles get into deeper urban environments with more buildings, you lose signal. So there are not enough satellites in view, and then you just lose the vehicle. You don't know where it is. So if you're using multi-constellation and benefiting from Galileo, you're going to have more availability of the satellite signal, so more position fixes. So you're going to be able to track better where every vehicle is. When it comes to the service provision, so how it impacts the user and how we operate the service, having a multi-constellation receiver just makes the pickup process smoother, because if you remember how I said that you don't have physical stops, what could happen is imagine that someone is requesting the service in a really big avenue, really wide with many lanes on one side of the avenue. But turns out that the accuracy is not good enough to know on what side of the avenue the user is. So what's going to happen is that the driver is going to receive a location that's misleading for him. So when he arrives to the avenue, he's going to see that he's on the wrong side, and maybe it will be very difficult to turn around, and it will just make the pickup process more tedious. Another impact that it can have is increasing service speed. Why? Because if we are seeing the traffic data from the control center, and we have very accurate positioning of the vehicles at any time, if we detect that there are slowdowns in traffic, or there are parts that are very congested, or a road has been blocked, we can react very quickly, and we can tell the drivers to turn and change their route, detour, so that they can avoid this kind of situations, resulting in the end more speed, so shorter trips for users. When it comes to sharing information with users, this is very obvious. If we have a more accurate positioning of the vehicles, the information that we can give to users about it is also more accurate. So the position that they're going to see on the app, on the user app, is going to be more accurate, and also the time of arrival that we estimate is going to be as well more accurate. And two new applications, this will allow us, the fact that we have an accurate satellite signal position of the vehicle, will allow us to track driving behavior. And this is relevant because you could, for example, detect whenever a driver is not complying with the designated route, so exits the designated route, and you can see if there was any problem or why that happened. And on the other side, you can even track how the driver is driving, like the quality of the driving. So for example, detect if there are many sudden accelerations or brakings, or if the driver is speeding. And another important feature is the validation of the route. And this is especially relevant if you're operating this kind of service for public bus service, so public transport. Because there's going to be a transport authority that's going to tell you, okay, your platform is telling me that this is the route that the driver had to perform this day, but I wanna have a proof that the driver actually picked up these passengers and that the driver actually drove through this route. So the only way to have a real proof is to have a very accurate and a lot of availability of the signal and a very accurate signal, because that way you can go to the public administration transport authority and be like, here's exactly what the route that the driver did. Okay, so now we've seen the impact that GNSS can have in this kind of service, but I just don't want to tell you, I want to show you. And that's why I brought a real use case of a DRT service. And let me explain that this was an experiment that was carried out in a European project called GALILEO for Mobility. And this happened during the lockdown, the beginning of the pandemic. And what happened is that there was this one user that kept using the bus, even if we're all in lockdown. Could have been doctor, we don't know. And what this allowed us to do is that we could, so the same itinerary was being repeated over and over and over every day. So we thought, okay, so why don't we change the device that we're using for the driver app? The driver uses a tablet that guides him through the route. Why don't we change it to a Galileo-enabled device so that we can see how the receiver performed doing the same route before before we put a Galileo-enabled receiver and after. And the result of that you can see on the graph on the right. So the horizontal axis shows the error, so the distance in meters of the error, and then in the vertical axis you have the samples, the number of samples. So as you can see, with the Galileo-enabled tablet, we have more samples below the 2.5 meters compared to GPS. So it just means that accuracy was better in Galileo, and here you can see it. So most of the samples were under 2 meters, and it wasn't the case for GPS. And another real case that I want to bring to you is this. It's not a DRT service, it's a bus service, but it's just as illustrative to see how a multi-constellation receiver performs. These were recordings that the bus operator did in different periods of time. One period where they didn't have a multi-constellation onboard equipment in the buses, they had GPS-only receivers. And the second period on the right with the new receiver, where they installed, renewed the technology on board of the buses and installed multi-constellation receiver. So all these yellow lines you're seeing on the left are recordings of the bus going through the same street in different days. And as you can see, the signal just wasn't accurate enough, and at some point it wasn't accurate at all, like couldn't even follow the right road. And on the right, instead of having this mess you can see here, we can see very, very precise and accurate positioning, following the road perfectly. What this impacted, like how this impacted the operator in numbers, is that they went from having errors that ranged from 40 to 60 meters to having errors that ranged from 2 to 5 meters. That's very precise for urban environment. And the valid positioning, which is an indicator that they use to say how long they've been able to track properly where the bus was, went up by 7 percentage points, and up to 97% of the time. So 97% of the time they could properly track where the bus was. Second service I want to tell you about is a scooter sharing service. And I'm talking here about the mopeds. I'm not talking about the kick scooters, because we're going to have a wonderful presentation after me from a kick scooter operator and other sorts of vehicles, you'll see. But this time I want to focus on scooter sharing, moped, and let's see what applications does geolocation have in this kind of service. So for fleet management, there are 2 operations that are critical in this kind of services, and this is because they are not station-based. The mopeds, they're free-floating, how they call them, which means that they're just parked freely in the city. So the operators working for the scooter sharing provider company, they need to know where every vehicle is for charging them, because they're usually electric mopeds, and they might need to swap their batteries for a charged one, or they might need to move them to bring them to charging stations. So they need to be able to locate where the vehicles are for charging them, and also rebalancing, which is an operation that means relocating the vehicles in case some of them accumulate in a specific area of the city, and then you don't have vehicles in other areas of the city. And sometimes this is even a requirement from public administrations, from city councils. For example, in Madrid, the city says how much of your fleet, like what percentage of your fleet you must have in every district in the city. So if you're not complying with these percentages, you need to rebalance your fleet. Another use geolocation has is for theft alert and vehicle retrieval. What this means is you can detect with geolocation whenever the vehicle is being moved without an associated reservation. So if no one has reserved it, but you detect that it's being moved, it's probably being stolen. And then you can use geolocation to retrieve, to locate where the vehicle was taken and retrieve it. When it comes to service provision, it's used for locating the vehicles, because since I said it's a free-floating scheme, free-floating service, users need to know where the vehicle is. So they open their user app and they see on a map where the mopeds, where the vehicles are. It's also used for billing at the end of the trip. And it's also used for geofencing. And I'm sure you're familiar with this, but these services, they have a delimited area where they can operate, not operate, but where the vehicles can be parked. And the user also sees that on the map, on the user app. And so the operator of the service needs to know where the vehicle is being dropped, because if it's dropped outside of this geofenced area, you won't be able to finish your trip. And then similarly to DRT, for optimizing service performance, looking at geolocation and how the vehicles were driven and in what areas of the city, you can make better estimates of where they should be, where the demand is located and where the vehicles should be located to optimize the service. Now, how does GNSS impact a scooter sharing service? Well, for fleet management, for charging operations and rebalancing, it means lower logistics costs. And this is a very important cost for the operator, the logistics of charging the vehicles and rebalancing them, moving them around. And so the faster they can find every vehicle, the better it will be for the operator. The lower the logistics cost of these operations will be. Because you might not need as many people finding vehicles if they can find them faster and get more vehicles in less time. And then, obviously, in case of theft, having a more accurate signal lets you detect better when these situations happen. And one thing that sometimes happens is that users even appropriate the vehicles. So they might park them in a private area, like in their own parking, for example, in the city. And it's very hard to detect sometimes if the parking is it's inside the building, but right on the side of the sidewalk, on the side of the street. It's very hard sometimes to detect if the scooter is inside a private garage or is on the sidewalk parked. So for these cases, Galileo could help. And when it comes to service provision, having a more accurate position reduces the friction with the user. What does this mean? Okay, so we said the user needs to find the vehicle through the user app, right? Sometimes the accuracy is so bad in deep urban environments that it might be showing you misleading information such as the vehicle showing in a street where the vehicle is not. So it might be showing on the street that's parallel to where the vehicle really is, and the user might go there and not be able to find the motorbike. What this does is just It makes the user spend more time to find the vehicle. And also a big impact it has is if you want to end the trip and you left the vehicle right at the edge of this geofenced area, but the accuracy is not good enough to know that you're actually inside, right on the edge, but inside the area, then you're just gonna not be able to finish your trip, and you're gonna end up paying more for the service because it's taxed by the minute. So you're just gonna spend more time to return the vehicle, and this just creates frustration for the user. And all of this can be improved with Galileo. And another application, this is quite innovative, could be to detect unauthorized parking automatically. What happens is that, for example, in Barcelona, you know, in some parts of many parts of the city, the mopeds can be parked on the sidewalk, but not everywhere in the city. Sometimes if the sidewalk is narrow, there cannot be motorbikes parked there. So one thing that the operator could do to help the city detect whenever a user is not parking the vehicle properly is to, thanks to an accurate positioning, to know if the vehicle is on a sidewalk where it's not authorized to be parked, and automatically send this information to the authorities so they can go and find and remove the vehicle, and the operator can find the user. All right, so in this case, I also want to show you some real case about scooter sharing operator. This is data that was collected during another European project called GMOTID. And I'm showing you on the left a scooter that was parked in a deep urban environment, so with narrow streets, tall buildings, and on the right, the same vehicle driving around a less urban, semi-urban environment. So what you can see on the left is the moped, the vehicle was parked here in the yellow point. And in purple, you can see what the GPS only receiver was returning as a position. So as you can see, it keeps jumping around, like it's not able to locate the vehicle where it is, and it keeps on changing. And in red here, you can see the different locations that the Galileo-enabled receiver provided. And you can see it's quite accurate. It's not right on the street, but it's very close to where the vehicle was parked. And on the right, while circulating, here you can see that there's a problem with availability. The purple position fixes is how many position fixes we got from the GPS only. And then in red, you get all the position fixes from the Galileo-enabled device. There's a problem with availability, and there's a problem with accuracy. Here, for example, you can see that. Okay, so I want to put this, I hope this cases inspired you, and seeing this application in cases inspired you in how you can use Galileo, but I want to put it very straightforward for you. So, as a startup, how can I seize the benefits of Galileo? So if you operate a fleet of vehicles, like the case I just showed of the scooter sharing operator, you can equip your fleet with multi-constellation receivers to benefit from Galileo. If you are gonna purchase new vehicles, make sure that you choose a multi-constellation receiver for them. They're available in the mass market, like there are mass market receivers, there are multi-constellation available, and they are cheap. They are not significantly more costly than GPS-only single constellation receivers. If you have a business-to-business or business-to-government activity, and you can influence what devices they use to operate your software, for example, in the case of the DRT solution that I explained, you can become a prescriber of Galileo-enabled mobile devices. It's the case of changing the tablet that I explained for the DRT experiment. So if you are the DRT technology provider, and the bus operator is gonna look at you for deciding which software, which hardware, which device is the best one to operate your software, you can prescribe them a Galileo-enabled device, and they're gonna get a better quality service from you. So you're gonna benefit from that. And if you don't own any fleet of vehicles and you don't influence the devices that your end users or your clients are using. So if you only rely on positioning data from your end users' mobile devices, what can you do? Well, you can get the most out of Galileo by working with raw GNSS measurements. So I want to show you just a couple of resources that you could use for this. Google has developer tools for looking at GNSS raw measurements from Android devices. Unfortunately, it's not as easy for Apple devices. So if you've developed an app only for iOS, you're not lucky in this. But if you have an app for Android devices, you can exploit GNSS raw measurements, and you might get interesting insights for research and development purposes. Like you might find new applications that can improve your value proposition by looking at this. Just a clarification, the position fixes got from multi-constellation don't look any the data doesn't look any different than if you're getting them from one constellation, but you are going to be able to see the different satellites that were in view and how many of those satellites belong to each constellation, how many Galileo satellites you could see, etc., etc. And another interesting resource is one available on the EUSPA website, formerly known as GSA, the European Space Agency, which is a white paper on why and how to use GNSS raw measurements. It's very interesting. Check it out. Because you might, if you're interested in this topic, you might learn a lot. Now, for the last part of my presentation, I said I wanted to show you also what we can do for you going forward. And that's why I want to tell you that we've developed this Galileo demo kit, which is the goal of this kit is to demonstrate to you personally how much better a Galileo-enabled multi-constellation receiver with the latest technology performs compared to GPS-only receiver. So we have developed this hardware that has inside a GPS-only receiver, which is representative of the mobility market, and also another receiver that's Galileo-enabled, multi-constellation receiver, that's also representative of the mobility market. And we can run a demo for you where we will take this kit, we can install it in a vehicle. The installation is super easy, just needs a 12-volt connection for power, and then we bring our own antenna. And then we can do a little route wherever you're interested in a part of the city that you find challenging. And we can show you on real time the performance of both receivers in this web server that we've developed. So please, if you're interested in this, if you're interested in looking at how different they perform and the kind of accuracy you can get in urban environments and in your kind of vehicle, if you're operating a fleet, if you're interested in this, please contact us and we can organize a demo. It can also be an online demo, so we can do the same with this kit in Barcelona where we're based, just drive it around the city and show you online the results of the demo. So if you don't have time for physical demos, no need to worry, we can run a demo online for you, just showing you the web server and the data we collect. So that was my presentation. And thank you for your attention, and I'm looking forward to your questions.
Thanks a lot, Sergi. Thank you, and it was interesting also the end concerning the demo kit. I think it's quite clear what we can do with it. Okay, maybe we can directly switch to Alvaro for your experience feedback of from Ruby. I let you share your screen.
Yep.
Thank you very much.
Hi, everyone. Thank you for your presentations. And yeah, I'm going to try and just share 1 second, please. Yeah, there we go. Okay, can you see my screen?
Yes, perfectly.
Sorry. Okay, good. Yeah, so I'm going to be speaking from Ruby. I'm I'm going to briefly introduce the company and then walk the audience through some of the use cases for which, we use geolocation, but more specifically those use cases where geolocation becomes critical to what we do. Okay. So Brebi is a shared mobility operator. We operate a variety of vehicles, from scooters to bikes to mopeds. We're a team of 100 people. We operate mostly, I'd say, only in Southern Europe, in Spain and Italy. And this slide is a bit outdated, but we're currently operating in 15 service areas. Okay. We've invested, our IoT module can connect to the different location providers, depending on which one has a better signal. Okay, there's a very good reasons to why we invest in good IoTs. The first one being this is a very competitive industry. Okay, you're always pushed to perform better. If you don't, competitors will. And geolocation is a very important thing in everything we do. Okay. The second one is public space is limited, and local regulations are getting stricter and stricter as time goes on. So a lot of cities that are have already addressed the fact that free floating is a delicate way of operating, and most of them they're tackling the issue head on, and we'll see how. Okay, mostly restricting the public space available for these type of vehicles. Okay, and then just having a positive impact in the communities we operate. We'll see how location is critical for that. Building on what Sergi showed us, certainly geolocation data is messy. Okay, sometimes no matter how good your positioning is, it's still messy, just given the orography of cities, right? Here you can see some of, just 3 rides with Brebi, the GPS points that we get. It's obvious that, people are not traversing buildings, and they're not, cutting corners through physical walls. But still, this is pretty much the data that we are forced to work with, at least when we're talking about riding behavior. Okay. Overall, I'd say, micromobility is challenging. It's a challenging environment. Every data point that comes into our business is probably geolocalized. It's the only way that we can have things under control. Things like maintenance, so things as simple as knowing where a ride is ending. Sometimes, it might seem easy, but sometimes it isn't. Knowing where to deploy our scooters, where's the best, what are the best options to maximize the efficiency. All of that, is data that is geolocalized. Okay. It's challenging because normal road networks don't apply. So if you look at the road network for cars or motorcycles in the city, it's somehow comprehensible. But these micromobility vehicles, mostly scooters and bicycle, normal road networks, they don't apply. So they will ride, even if it's not permitted, they will ride on sidewalks, they will ride through parks, they will use walking lanes and sidewalks. And, that is out of the common. So you've got to apply special rules, and sometimes it's not very straightforward. This business is very operationally stressed. So we're always changing batteries, we're always deploying, we're always doing maintenance. So we are operationally 24 hours 7, essentially, to keep the fleet operative. As we said, local regulations are getting stricter. We're always data stressed. So we're always in the need of a lot of data and real time and reliable to make smart, the decisions that we need to make. And obviously we're forced to innovate rapidly. Okay. How could geolocation hurt the business if it's not good? Okay, from a user perspective, again, this is building on what Sergi said, but you don't want unhappy users. They become less loyal, less likely to recommend, simply because sometimes they want to find a vehicle and they can't. Okay, sometimes it's just as simple as that. Operationally, it's a waste of time. We tend to lose vehicles because we simply can't find them, and it's an additional obstacle to our day-to-day stressed operations. And from a business perspective, essentially, it's an economic. It has a negative economic impact. Okay. Okay. So let me walk you through a couple of very precise examples of how this is becoming a reality. As you see here, this is the way cities are moving to designate specific parking areas for scooters. And if you see how small that is, that's about one at most two car spaces that have been made available for scooters. And there is a huge difference between parking on the sidewalk or parking on the parking spot itself, and that's just like a few meters apart. Okay, if we're not a bit ready to know this distance just by the location that we get from satellites, we have to go into like data and do like clustering and things to try and see if the scooter is on the sidewalk or it's on the parking spot. So it becomes challenging. Here we have a map, with sidewalk width. So we've mapped the sidewalk width. As if you can, there's, given certain city regulations, there's a minimum sidewalk width in which you can park a vehicle. And even if we can map out these kind of things, knowing that the scooter is on the sidewalk or not, becomes a real problem. Again, because just a few meters makes a huge difference. Okay. Also, more restrictions. Driving on designated lanes. Right, as you see, the left is Barcelona, the right is, to be honest, I don't know. I think it's a city up on Northern Europe. But there is like a designated city lane, and you can definitely drive through it. But what you cannot do is drive on any other road that you see on that picture. So you cannot ride on the sidewalk. You cannot drive on the two lane that's to the left. And the difference in location is just a few meters, right? So understanding if your users are behaving properly is like a very, very precise kind of thing that we've got, that we're forced to do. Again, and coming back to restrictions, cities are imposing slow zones, no driving zones, like specific roads in which you have to lower the speed, and all that is very precise, right? So we get very precise like GPS locations where that happens. In many other cities, you simply just cannot drive down specific roads. So 2 lanes, 3 lanes. So yeah, and again, this is like a good picture, right? So this woman, isn't like properly driving. She's on the sidewalk. She shouldn't be doing that. But probably she could drive on that street because it's a residential street. It's an important difference. A lot of the times we, as an operator, we get the responsibility to ensure that people are making a good use of the public space. And it's obvious here that it's a very tough thing, right? In order to solve some of these challenges, we do a few things, which are, I want to say they're pretty standard, I'd say, I guess, right, in the industry. One of them is applying filters, common particle filters, to try and have a better picture of how vehicles are moving and don't rely only on location data. The other one would be, and again, this is pretty standard, map matching techniques, okay, by which you are mapping GPS points to the nearest road network. Sometimes we do a combination of both. So we do some clustering, some common, and we map match. So yeah, it depends on how complex the situation is. And if if we look at this picture, this is the road network provided by OSM, OpenStreetMaps. As you might know, OpenStreetMaps is the default open source provider, which is pretty much used by everyone that's doing anything in the mapping industry. So, coming back to my earlier point, personal mobility vehicles can pretty much drive on any of the roads that you see here. So even if you do apply some kind of clustering and map matching techniques, there's a lot of roads that are available for you to match locations, right? In the case of cars, this and other vehicles that use normal road networks, this is much more simplified. Still challenging, but simplified. That's not the case for micromobility. So overall, we're presented with a few challenges, right? That just summarizing what we've just seen. Most of the time, location is not as precise as we need. Okay, and we need to go into post-processing that data to understand what is happening. If we do apply filters, it's computationally challenging to do it real time. Okay, as we saw, like Kalman or particle filters, map matching. In real time, it becomes a challenge. And if we want to do like a really good job, we need to equip the vehicles with more sensors. Okay, so we need things like barometers, gyroscope, accelerometers, especially for filtering the data and it becomes critical when we lose GPS signal, for example, in a tunnel. Okay. And just to present you with one of the, I'd say, most innovative projects that we're working on right now is collision avoidance, and this is it's a project that involves trying to detect or trying to predict when a vehicle is going to have a collision. And in this model, we have three things that are critical. One of them is obviously location, and the other one is a mix between like a radar and a vision system that we're putting together. But again, if you want to do things like this, right, and they're everything is very sensitive, and you need everything to be very precise, and most importantly, you need it to be like that in real time, right? So there's a lot of like processing and stuff that needs to go right. I'm going to stop presenting now. I hope I saw. And that summarizes, I think, nicely how we work with data in the most challenging of the environments that we have. So thank you very much.
Thank you very much, Alvaro. Yeah, it was interesting. I think we were more and more in the concrete life. So with you, Sergi, and now with Alvaro. So thank you very much. I think we can go directly to the question and answer, as we have 20 minutes left. So no answer were put in the chat for now. So so don't hesitate now to ask if you have first question. Otherwise, I have some question that recently some startup asked me, and I think it could be the opportunity now to raise them. Those very concrete questions, but maybe the attendees that are still here, because we have some loss. Do you have specific question for Alvaro, for Sergi, for Josep, for general question about Galileo?
I think there's a question in the chat, isn't there, Laurent? But do you?
Sorry, I missed it. Sorry. Yeah, and it's okay. So thank you for this question. So I think it was directly asked to you. So do you intend to use Galileo, HS, and OSMNA Sorry, I'm not familiar with that, in the future? So I think it's for you, Alvaro.
Well, so I guess like an important an important point I'd like to understand is that from our side as an operator, what we most care about is, you know, that we don't really like know the in and outs of the different geolocation technologies, right? So we read papers and we understand that it's going to be like more precise, and we kind of know why. The specific technologies of how that happens is not an area that we focus on, right? So if Galileo is better at positioning, then that just makes the industry better. So I think that pretty much, I just want to give the broader vision that, you know, we'll use, and in general, what people will use is what is more precise, because that's what like gives more value to companies, at least like ours. And I hope that answers the question.
Okay. Now, if you want to intervene with the microphone, feel free. Okay. Yes, Philip, you can go ahead.
Thanks. I have another question because I'm coming from the laboratory certifier side, more or less, so I know how to more or less type-approve these type of systems currently and in the future. And there's also the question: did you address also certain critical scenarios, like for example, you addressed multipath, but also for example jamming or spoofing in this project?
Now, if I may jump in, we have well identified the jamming and spoofing issue, where I have explained that Galileo is more robust against these attacks. But this project, I remind you, is a coordination support action, meaning that it is not in the scope of the project to run actual pilots besides the demonstration that we can do by using the Galileo demo kit. So the Galileo demo kit that Sergi presented is mainly meant to provide concrete and very easy to understand data on the accuracy that can be obtained if you use multi-constellation as compared to GPS-only receivers. And here you can use it however you want. It's at your disposal. But that's the only, more tangible, real-life tests that we will run in the project. We will not be addressing this jamming or spoofing effect. But I tell you that from a technical perspective, what it does is, under our scope, is to educate stakeholders that make questions such as yours, which is whether or not Galileo is more reliable against these attacks, which is the case.
Okay, thanks.
Okay, maybe I can ask one question that has been recently asked to me. So, from a business perspective, and to anticipate what will come, and the new solution for micromobility based on smartphones. Actually, it's a double question. On the one hand, do we know the share of smartphone today compatible with Galileo, and do we know if at what time in the future every smartphone will be compatible? And on the other hand, will the 5G will allow also some will it be interaction with the new 5G context, or are there some inputs related to that? This is a good question.
Yeah, if I may jump in again. So just a brief clarification on the previous question, because I think it's important. Galileo is the only GNSS in the market that is multi-frequency, meaning that it operates in different frequency bands. This is what makes this system particularly robust against spoofing and jamming the signal, because you can try to trick the system on one single frequency, but it's much more complicated to do it in other frequency bands. And there are some studies that have been performed by independent entities such as Broadcom, proving that this makes Galileo particularly robust against these attacks as compared to GPS, which only operates on one frequency band. That's the technical, more technical answer to your question before. And regarding the level of penetration of smartphones that include multi-constellation receivers, I don't have the latest figures on this right now, but this is an information that you can easily find on the USPA website. They have a search engine where you can search by brand or by model which concrete smartphone does include a multi-constellation chipset, and you would be surprised to realize that, for example, many of you attending this webinar today, your own smartphones are Galileo enabled, even if you don't know. You might just think that they are GPS only, but they are not. I mean, if you are using modern smartphones, the modern iPhones or the modern Android devices out there, all of them include multi-constellation chipset, because as I think it was Sergi who said that in terms of cost, the difference in cost is marginal. It costs almost the same. The hardware chipset costs almost the same. So this is to say that it pays off to use Galileo. On the other hand, you as a user might have a very accurate geoposition because you are using one of those smartphones. However, if, for example, the kick scooter that you want to book, for example, does not include an IoT platform that makes use of Galileo, it might be the case that you are very well geolocated, but the vehicle that you have booked is some meters away and is blocked in terms of line of sight with a building, and you simply don't find it where it's supposed to be. And this might generate frustration, this might generate friction, and this is the kind of things that we need to avoid.
Yeah, I don't have the figure either of how many smartphones in the market are Galileo enabled, but I know most of the smartphones available on the market to buy today are Galileo enabled.
Okay.
So the penetration of smartphones, owned smartphones that are Galileo enabled is going to be quite big soon, I'm guessing.
Okay. Yeah, another very practical question was asked also. Does Galileo, does it allow the faster collection of the geolocation points, which has an impact on the power saving of the device? Do we have some clue about that? Because to keep the the location of the point we are following, so the device, we are collecting geolocation points, sorry, at a certain frequency, and this takes a battery so power. It takes power from the smartphone, for example, and this is an issue. As we know, and the smartphone, even the latest generation, have no huge battery. So, is it possible with the multi-constellation opportunity to try to catch at a lower frequency the location points?
What happens with modern smartphones is, because they incorporate multi-constellation chipsets, the time to fix a location that is good enough, the time to determine where you are located based on the satellites in sight that you use to compute your location, typically in average takes less time. You spend less time. I mean, your smartphone will spend less time to determine a good position, and because of that, at the end of the day, you will make a better, more efficient use of the battery. It will overall be a more efficient operation of your smartphone in terms of battery consumption. By the way, I have just shared through the chat the URL of the USPA, where you can check whether or not your smartphone is multi-constellation enabled. So you have the resource.
Okay, thank you. Okay, if there are no other questions right now, then I think we can close the webinar. Anyway, I will share the last slide. Anyway, we will post the video and the summary of the webinar on the website. And if you have other questions, or as Sergi explained, if you are interested for a demo, online demo or physical demo, don't hesitate to contact us. And if you have question later, we are at your disposal for that. Thanks a lot. Thank you, Alvaro, Sergi, and Josep. And,
thank you.
And see you soon. Have a nice weekend.
Thank you. Thank you all.
Ciao.
You too. Thank you all. Cheers.